Okay, hello and welcome. I'm Travis McEwen, and we are going to be going over Lab 6 for CIS 236. So let's go ahead and see what we can do. So when we open up, we're starting to get a little bit more in depth into actually setting up some networks. And in this lab, we're going to be doing not just the addressing of our systems, setting up basic configs, we're also going to be setting up a static route on our devices as well. So let's go ahead and start with switch 1. And where it wants us to go ahead and set a host name for our device. So we'll go in, we're in, remember, user exec mode. We need to move into privilege exec mode, so enable, and then into global configuration mode with configure terminal, or conft for short. We'll use the hostname command and we'll set it to S1. And then it wants us to also go through and set and configure our console and privilege exec mode passwords. So because I'm already in global configuration mode, we're going to set our privileged exec mode first. And we can do that by using the enable secret class, where class is the password. And then we're also going to set our console password, and that goes underneath our line con 0. So we'll go under line con 0. And remember, console port is how we use a physical connection to connect into the actual device itself. So that's what the console port is, and so that's where we're assigning this password. So to do that, we just use the password, and it wants it to be Cisco. And then remember, we have to apply it as well, so we use the login command. So that's step 1 and step 2. In step 3, they want us to prevent unsolicited and debug messages from interrupting your console session. So that also goes underneath the line con 0. We use the logging synchronous command. The logging synchronous command always goes underneath the line con 0, or it will go underneath the line VTY. In fact, you can put it underneath both and it will do the same thing. It just applies this command based off of how you are accessing the actual device itself. So whether you're accessing the device via a physical cable, the console port, or whether you're accessing it through, say, the VTY, which is through Telnet or SSH. So that is step 3 done. Step 4, configure a banner. So we're going to back out one line back to our global configuration, and we're going to set our banner message of the day. So we'll say banner MOTD, and we'll just say exactly what it wants, which is restricted access. So then we're going to also disable unwanted DNS lookups, which is step 5. So we'll say no IP domain dash lookup, and that will apply that. And then the next thing that it wants us to do underneath S1 is to also set descriptions on S1 for our links going to PC1. So we're going to go ahead and take a look at that. And so a little bit of a typo in the directions. It says also wants us to go over to set the description going over to, say it's going to S2. It's actually going to R1. So we'll go into our port FA01, and we'll say description. And in this case, our description is just to PC1. And then we are also using G01 as well. And we'll say to, in this case, it's over to R1. So that's our descriptions for those devices. So if we check results, we can take a look and see kind of how we're at. So if we're on S1, we should see Basically that we've configured a good chunk of what we need so far. So we do need the default gateway still, and we also need to kind of configure some additional steps, but that we haven't quite gotten to yet, so that's okay. Everything else seems to be working based off of what we were supposed to be doing so far. So all that's good. One thing that we can do again is if I don't want to have to retype in all those commands over into S2, I can do a show run. I can copy everything that I've put in there, open up a notepad, paste it on in, and make my changes to my device or into my configuration here. So we'll say that's to PC2 because it's going to FA01. And then it's also using the gigabit Ethernet as well. And so this is going to R2. And then our restricted access, we'll just make it a little bit easier for that. And everything else should look just fine. So now that we've got that, easy thing that we can do, we can copy everything out of this notepad, open up our next switch, go into global configuration mode, right click and say paste. And then if we do a show run, just show run from this run level, we should see everything that is all set. So we have our password set, we have our host name set, no IP domain lookup, descriptions look like they're set correctly, so that's good. Underneath our line con 0, everything looks fine, so everything applied. So that is good news. So if we can also verify by just going to check results, and we should see that everything on that we did on S1 should be checked off on S2 as well, and they are, so good news. All right, so next thing that we're going to do is go into the step 7, encrypt and enable console passwords. So to encrypt passwords, we use the service password -encryption command, and that will encrypt our password. Next thing that it wants us to do and we're still on S1 here, is also to configure a username and password with full admin privileges. So again, this is just underneath our global configuration mode. We say username, CIS 236, and we can't say password. We could also say secret. We could also say a privilege. And if we specify privilege level, full privilege level is basically the lower the number, the better. So in this case, we'll say 0. And then we'll say secret, and it wants the password to be class. And so that'll set that. The next thing it wants us to do is to configure a default gateway as well. So the default gateway for this device on S1 is 192.168.10.1. So we'll say IP default gateway 192.168.10.1. Now, again, remember the default gateway command is only needed on a switch if you want it to be able to be remotely managed from another network. So right now, remember, a switch is a layer 2 device. It doesn't know what an IP address is. So it only works. So if I set up an IP address on it and I set it up on the VLAN, it only knows how to respond to messages within its LAN, within its given network. So if it receives a message from any other network, it will just not know what to do with it because it doesn't know where to forward traffic to. It doesn't have a routing table. So the default gateway command tells the switch, hey, if you see traffic that comes from a different network, i.e. from, say, like PC2 over here, instead of dropping it, send that traffic to your default gateway, and your default gateway will take care of routing it for you. So it's its doorway out of its LAN. So it goes, okay, if I don't know what to do with it, instead of dropping it, I'm going to forward it to router 1, and router 1 will then be responsible for routing the traffic to the proper destination or to the proper next hop. So that's what our default gateway does for us. So very important job. Okay, so next thing that we want to do is we also want to set up telnet. So to configure telnet underneath global configuration mode, we go to line VTY 0 through 15, which is what the directions want us to have, because it's saying that it wants to have a total of 16 concurrent telnet connections. So 0 through 15, if we're counting at base 0, that gives us 16. And we'll apply our password, which is telnet. And then remember that we do have to apply login, the login command. And there we go. So after that, we'll go all the way back to our privilege exec mode, and then we're on to step 11, which is to save our configuration. So we'll say copy run start, and that will save our running configs. Now, again, if I wanted to not have to do all this, the things I can do right now is or if I did not want to have to redo all of this over on the other device, I can copy everything that's on this device, go back to here, paste it into a notepad, and then make the changes that I need to. And even though these commands already exist, it is a-okay. Or so that some of the commands already exist that I've already copied in. It's fine. It won't hurt the system. But if I really didn't want it, all I'd have to do is just delete it from the line, and it's not gonna worry about running those commands again. So same thing, I could honestly delete all of these interfaces. Including all that interface, including all of these, including the banner message of the day. And I actually don't need the line con 0 because I've already done that over on the other side too. So really, I can just enter in these commands. So I can just copy this, go over to switch 2, go back into global configuration mode, paste the few commands that I have, and that should get me back up to what I need for between the two devices. So we can see on S1, everything's all set, minus the VLAN, but we haven't gotten to that yet. And over on S2, everything's all set, nothing, and minus the VLAN because we haven't done that yet either. So neat. So that's a little trick. Again, remember, you can type out your commands in a notepad and just paste them right on in, and it will accept it. So that's kind of the nice thing of these systems. So overall, part 1 is done. So part 2, we're going to configure the PCs. So we're going to go over to PC1. We're going to go to our IP configuration, and we're going to go up to our addressing table here, and we're going to input what we need for our addresses. So we'll say 192.168.10.50. Our mask is 255.255.255.0. and our default gateway is 192.168.10.1. Now, again, remember your default gateway is very important. It is the doorway out of your network or out of your LAN. So this default gateway tells this PC to say, hey, if you want to leave your LAN, send the traffic to router 1. And router 1 will take that traffic and determine where to forward it to next so they can make it to the destination that PC1 wants to go. Without that default gateway, PC1 would only be able to communicate within its LAN, and it would never be able to send traffic out past that. So default gateway is very, very important when you set them up. All right, so on to PC2. We'll set 192.168.20.50. And then we'll also set its default gateway as well. Okay, so part 2 is all done. On to part 3, which is to configure S1 and S2 with an IP address. So we'll go over to S1, and it wants us to set an IP address on the switch. So again, remember, a switch is a layer 2 device. I cannot put an IP address on any of its physical interfaces, so it only can be placed on the VLAN. So we'll go into global configuration mode. We'll say int VLAN1, and we'll apply the IP address that's in our addressing table. So we'll say IP add 192.168.10.2 and apply the mask. And then we'll turn the port on with a no shutdown command, which brings the port to an up state. We'll go over to the other switch. We'll do the same thing. We'll go into conft. We'll go into int VLAN1. We'll apply our IP address with the IP address command. Apply our mask afterwards, and then turn the port on as well. So now that we've got that set up, we should have everything done in part 3. So we're going to go ahead and move into part 4 now, which is over on router 1. So on router 1, we'll go into global configuration mode, and we're going to go into our gigabit 01 interface, which is our interface going towards PC1 over here. And we're going to apply the following address to this interface. And that interface is the default gateway for these other devices. Now, we just call it the default gateway. It's just the first usable IP address in this network is typically what the default gateway is. So we're going to say IP add 192.168.10.1. We're going to apply our mask. And then remember, a router, its ports all start in a administratively down state. So we have to turn them on, similar to what we did with the VLAN by entering in the no shut or no shutdown command to turn that interface on. Now we're also going to configure our serial interface as well. A serial cable is a very old cable. You don't typically see them anymore. Another way of thinking them, you might have heard of them called this, which is a T1 line or a T3 line. They're very, very slow. You don't typically see them anymore. Maximum speed for these cables is typically, about like a T1 is 1.544 megabits per second. So pretty slow. You don't typically see them very frequently anymore. It's old technology, but still something that you might see. So it's still good to know how to configure it. Grand scheme of things, it's pretty straightforward. So when we configure it, we do the same thing. We'll go into, it's just an interface, so we just say int serial 000, and that's that interface right over here on R1. Oops, didn't mean to make that full screen. And then we apply the following IP address. So we say IP add, and in this case, we're applying 10.0.0.1, and we're applying a different mask than what we do here. We're applying a 252 mask. Now, I'm going to make a video here in a little bit going over IP addressing, so don't worry. But basically, this means is I have two available IP addresses in this network, one for this router and one for the opposite side. And then same thing, we're going to turn this on as well. We're going to say no shut and bring that port on as well. Now, another important thing to note with this is you can see there's a little clock symbol right there. This denotes that this side of the serial cable is what's known as the DCE end. And the other end is known as the DTE end. So the important thing to note is generally the DCE is the clock rate. It defines how quickly data is allowed to travel back and forth. So what different types of speeds is allowed to actually transfer across that cable. You don't typically see this anymore, so don't worry about it too much. But the DCE side is responsible for setting the data transfer rate between the two sides. So typically, the DCE was always who the network provider was, and the DTE side was typically you, the customer, or the company that was getting the serial cable. Again, older tech, don't worry too much about it. We'll use it a little bit, but not a whole bunch. So if we wanted to set the clock rate, we'd say clock space rate, and clock rate is set by bits per second. So we're going to set a clock rate of, likely there's already a clock rate set. I'm just showing you how to set the clock rate. Well, we're going to set a clock rate of 128,000. Which, if you think that's a lot, it's really just 128K kilobits per second. It's pretty slow. But if you are experiencing issues and you're like, hey, why is no data working back and forth when you're working on serial cables, it's likely the clock rate hasn't been set. So you need to remember the clock rate goes on the DCE side. Easy way to remember it is DCE, C stands for clock, make sure you have it. DTE, T stands for Tyrannosaurus Rex, who has little tiny arms, needs someone else to tell him the time. So, now that we've set our clock rate, we've also turned our port on. Everything should be good on this side. So we're going to go over to the other router and do the same thing over here. We're going to go into our G01 interface and going up to our addressing table. We're going to assign the correct routes. So we'll say, or IP addresses rather. We will do routes here in just a minute. We'll say 192.168, 20.1. I'm missing my dots. And we'll turn the port on. We'll go into our serial interface. And we'll also set our serial IP address here, which is 10.0.0.2 with a 252. And we'll turn this on. Now, again, because R2 is the DTE side, I don't have to set a clock rate, so it's all good on that end. So, cool. Everything should be going green here in just a sec. There it goes. So then, last little bit of stuff that we have to do is to set static routes. Now, a static route tells the router how to forward traffic, or it tells the router that a network exists and it tells it how to get there. So we're going to go on router 1 first, and we're going to enter in the following command. So we're going to say IP route, and we're going to say 192.168.20.0. We're going to enter in the mask, and then we're going to enter in what's called the next hop IP address. So what this does is it says, this command is saying, hey, the 192.168.20.0 network exists. It is this size, which is the mask, so it's 255 IP addresses in size. And to get there, you forward the traffic over to 10.0.0.2. Well, 10.0.0.2 is R2. I'm on router 1 right now. So if router 1 sees any traffic with a destination IP address that exists within the range of 192.168.20.0, so in that network, so that'd be all the way from 1 up to 254, really, it will send that traffic over to router 2, and router 2 will take care of it from there. So then we'll go over to router 2 here, and we'll do the same thing. We'll tell it IP route, and we are telling router 2 that the 10.0 network exists. It is also 255 IP addresses in length, and if I want to get there, we send it over to router 1 at 10.0.0.1, which is my next hop. It's the next router that I'm handing it off to. So now that we have that configured, everything should work. If we want to verify that things are working, we can look at our routing table with the show IP route command. And again, we can see now that in router 2 here, I now have added this 192.168.10.0/24 network. So it says if I want to get to that network, I send it over to router 1 at 10.0.0.1. So if I go over to my PC, I should be able to ping 192.168.20.50, and the first IP address will fail due to ARP. That's okay. I'll just fast forward a little bit, and then you can see reply, reply, reply. So traffic is working. All right. Hopefully this was kind of helpful for going through a little bit of this lab. If you do have questions on anything, please feel free to let me know. All right. Thank you.